Hi, this is my final video in the 1160. My name is Ke Xinzhan, and my nickname also is the English name is the Cassie, and this is my student ID. So the first page is the Kepler's laws. The Kepler's first law states that its planet orbits the sun in the ellipsis, and the sun is located as the one focus of this. And the second law explains why the planets wipe out equal areas in the equal time. This means the planets move faster when it is the closer to the sun and slower when it is the farther away. And the third law is the most important for this experiment. It tells us the square of the orbital period in proportional to the cube of the orbital radius. In other words, distance the planets take much longer to the orbital the sun. And for the question 9, the planet-moon system, the moon orbits the planet, but the planet also moves slightly. This small whoop happens because both the objects orbits a shared central of the mass, called the barycentral. In a sun planet scenario, in a sun planet in the some plan scenarios from the question 1, 4, and 7, the center of the mass stays very close to the center of the sun because the sun is so massive. However, in the planet-moon system, the masses are more similar, so the center of the mass not at the center of the planet. This is why the planet show a visible orb as the moon orbits. And for the question 11 is the when the growth is the turned on, the growth squares represent half the astronomical unit. As a realistic scale, the Earth's orbit becomes the extremely large compared with the Sun. The planet also moves much more slowly because the orbit's radius is shown at its real value, about 41 astronomical units. And this is help us to understand why the planet is larger with larger orbits take much longer to complete one revolution. For question 4, I put on for the different distance the picture, and we can see the results, and we can know when comparing the numbers, the stronger the growth of the orbital period matches the prediction of the Kepler's law. As the orbital radius increase, the orbital period increase much faster. So it can know it is the follow the relationship is the t squares and the a cube. And for it is the question 5 and 6. It is the question 15 and 16. For the question 15, the fastest moving planet in the solar system is the Mercury, because it is closest to the Sun and experiences the strongest gravitational pull. The slowest planet is the Neptune, which is the farthest from the Sun. So the reason is simple. The gravitational force decrease with the distance. And for the question 16 of what did I learn? For this experiment, I learned how the gravity control the orbital motion and why the planets behave different depending on the distance from the sun. I also gained a clearly understanding of the centers of the mass and how two body systems move together. And most importantly, I learned how the Kepler laws appear in the real observatory data. And so that's all. This is my reference list. Thank you.